Here's Precal 7.1.2. It says, where do you think you're going? Working with one-sided limits. So today you will follow the travels of Benny and Bertha Bug. With their help, you will look at graphs of rational functions and piecewise defined functions from a bug's eye view to help convey the important concept of a limit in an intuitive way. So it wants us to sketch the graph of this rational function, and then it says here, let's get the graph. And you should be able to graph these just by knowing that it's a transformation of the parent function. So the parent function is, the reciprocal function, but this one says that it's moved up by 6 and right by 2. So I went right by 2. Did I say up by 6? Up by 3 and right by 2. So I went right 2 and up 3, and I made these little dotted lines. And then I just kind of drew a picture of the reciprocal function, like one of the parent functions that we have on the wall here in our classroom. And so that's not really what this question is about, though. This question is about, it wants us to place our finger on the point on the curve corresponding to x equals 5. So x equals 5 on the curve is right here. And then it says Benny Bug starts off at this location and crawls along the curve moving to the right. So here, this is a little picture of Benny Bug, and he's going this way. And he gets to the arrow, and the arrow on the curve just says that it's going to keep going and going, but this dotted line says there's an asymptote there. So where does he think he's going? Well, what they want you to say is that he's going to y equals 3, because as far as the y values go, that's what this graph is approaching. It's approaching 3. Okay, hopefully that made sense. And then 7-15 says use the graph at right to answer the questions below. Benny starts at the point on the curve corresponding to x equals 6. So here's x equals 6 right here, and moves along the curve to the left. So he's heading that way, just like the picture shows. And so he's climbing uphill. How high does Benny think he will get as he gets closer to x equals 3? Well, here's x equals 3 right here. So how high does Benny expect to get if he follows this little twig? Well, hopefully you can see he expects to get to 5. That's the height. So I know it might not make sense yet, but let's keep going. So letter B says Benny's sister Bertha starts at the point on the curve corresponding to x equals -2. So there's -1, -2. There's Bertha. And she's moving to the right. How high does Bertha think she will get as she gets closer to x equals 3? So this curve, how high does it go as it gets close to x equals 3? Well, it looks like it only gets up to y equals 1. So she thinks she will get to y equals 1. So here's more of an explanation. So it says, all the getting closer to language in the previous problems is the idea behind the topic of limits. A limit is a prediction based on a pattern of y values. Look at your graph of f of x equals 1 over x minus 2 plus 3. That's this one. As x gets greater and greater, f of x gets closer and closer to 3, doesn't it? It's closer and closer to 3. The corresponding limit statement is the limit of f of x as x approaches infinity is 3. See, the limit of f of x as x approaches infinity is 3. Letter A says, suppose Bertha starts at the point on the curve, this same curve, where x equals 5 and moves along the curve to the left. So she's here, but suppose she goes left. Where does she think she's going as she gets closer to x equals 2? That's the asymptote at x equals 2. So if that's the bug and she's going this way and she's getting very close to x equals 2, how high is she going to be? I think we can imagine that she's going to be like infinitely high. And then it says, copy and complete the limit statement for this situation. So the way that you would write it is the limit, I know you can already see it. I feel like I don't have enough room here. It's the limit as x approaches 2 from the right. So she's approaching 2, she's getting closer and closer to 2, but she's coming from the right instead of from the left. That's what this notation means. Of f of x is equal to what? Well, I want to say it's equal to infinity because she's going to positive infinity. So we're just going to say infinity. Okay, and then letter B says, did you notice the plus sign next to the 2 in part A? What do you think it means? Well, I kind of spilled the beans. It means that you're approaching from the right. This is called a one-sided limit. What do you think it means if there's a negative sign instead? Well, that would be that you're approaching 2 from the left. Like if I was coming this way and getting closer and closer to x equals 2, I'd be approaching it from the left, and I'd actually go down to negative infinity. Okay, we'll finish this and then I'll make a different video for the rest. Now use the graph from problem 7-15, which I think is the same graph, to evaluate each of the limits. Well, I kind of already said it. Well, this says as x approaches 3 from the left. So where's 3? 1, 2, 3. And I'm approaching it from the left. 1, 2, 3. So I think I would be at like 1, 2, 3, 4, 5-ish. Oh, wait. This is not the right graph. Let me get the graph. I'm so sorry. I don't want to re-record this again. The graph from 7-15 is this one. So we're approaching 3 from the left. We would get to 1. And if we approached 3 from the right, we would get to 5. That I'm going to start a new video for the next part of the problem.